Number 3, the function p of x equals 6x squared plus 11x minus 35 models the area of a rectangular horse pen Josue intends to construct. Factor the equation to find each side length. If Josue chooses his longer length to be 17 feet, how much does shorter length be? So to give you kind of an idea, let me draw a picture of what we're dealing with. We have here a rectangular horse pen. Okay, so right now I got a square. Let me change it this way. And we know the longer length is going to be 17. Now this equation models the area. All right? So we got to figure out how do we get these two side lengths. Well, this right here, if this is area, what we could do is factor it, and we get two lengths that multiply times each other. Now remember, area equals length times width. So really what we're doing is if we factor this, we'll find the length and the width. So I'm going to use this x method. Now remember, we have a times c on the top of the x, and the b goes on the bottom of the x. Now this is my a, this is my b, this is my c. So 6 times negative 35. You can type that in the calculator, but you'll go ahead and get negative 210. 11 would go down here for b. So we're looking for two numbers that multiply to be negative 210 and add to be 11. Okay, now I have a system for this. When they're bigger numbers like this, a lot of people might not know them on the top of their head. You could start and say, okay, would 1 and 210 work in one of these being negative? Would those somehow have a difference of 11? The answer is no, that wouldn't even be close. So then you would try, well, what about 2? 2 would have to multiply with 105. Get some combination of either a negative 2 or negative 105, give me 11. The answer is no. And you can keep working through this. Now, other people will see this and they'll know right away, wait a minute, negative 210, difference of 11. What about 21 and 10? Those have a difference of 11, and to make it positive 11, I need to make the 10 negative. And you'll stumble on it real quick. So these are our two numbers. They multiply to be negative 210. They add to be 11. So how do I factor from here? I take my a term, which is 6x squared, and I'm going to just put the 6x in the first parenthesis, along with this number, plus 21. It's positive, so it gets a plus. And then I take 6x again and subtract 10. Now this is equal to p of x. So nothing's changed, I just changed how it looks. Now, truthfully, that's not equal to p of x because you said 6x times 6x, you get 36x squared. So that's actually not equal to p of x yet. We have to simplify. The way you simplify is you say, is there a factor? There will be a factors of 6. Since I have two 6's, somehow we'll factor out 6 worth out of these two parentheses. So over here, I can see that 3 goes into both numbers. Well, if I have to divide out a factor of 6 and I'm dividing out 3 here, I must be dividing 2 here. Does 2 go into both these numbers? Yes, they have a GCF of 2. So I'm going to take out 2 of both those. So what am I left with? Here, 6 divided by 3 is 2x. 21 divided by 3 is 7. And over here I have 3x minus 5. Now this will equal p of x. So I don't do that line through saying it's not equal. This does equal. Now we have two side lengths. 2x plus 7 will equal 17, or 3x minus 5 will equal 17. One will be here, one will be there. Now let's figure this out. If that's going to be the longer length, and I'm looking at this is adding 7, this is subtracting 7, I'm just going to assume maybe this is our longer length. Let's try this one. If this is kind of a guessing game here. If I'm assuming this is the longer side, I would say 2x plus 7 equals 17. Again, I just chose this one because this is adding, this is subtracting, so I'm guessing this one's going to be smaller, this one's going to be bigger. Well, if I try to solve this, the first thing I would do is I would subtract the 7, and I would have 2x equals 10, and when you divide by 2, we find out that x equals 5. Now, if that's true, and this is the longer side, so again, I'm just assuming here that this is 2x plus 7. If that's the case, then this side needs to be less than 17 when we plug in the 5. Let's see. I plug in 5 here, and I would have 3 times 5 minus 5. So what did I do here? I'm plugging in 5. So 3 times 5 is 15, minus 5, I get 10. Perfect. That means this is, in fact, smaller, which means that side is 10, this is 17, so that we have an area of 170. So the actual question says, if Jose chooses his longer length to be 17 feet, how many feet must its shorter width be? It would be 10 feet. That would be your answer you're looking for. Now, before I move on, someone might be thinking, okay, you just assumed this was longer. What if we would have tried the other? Well, let me show you the problem we would have run into. First, I need to get a line here to kind of divide us off. So what I'm doing now is, what if we would have chose this side to be the longer length? What if we would have thought, I think 3x minus 5 is going to equal that 17 for the longer side. Let's solve and see what happens. When you add the 5, you get 22. So 3x equals 22, and then we would divide that by 3. And so we'd find out that x is 22 over 3, which is basically it's 3 repeating. So I'm just going to say roughly, approximately 7.3. So now what would you do once you found that out? You plug it into the other side. So we'd say 2 times that 7.3, and again, that's a rounded number, that's not exact, plus 7. 2 times 7.3 is 14.6. Add the 7, you get, again, let me do this, approximately 21.6. Do you see the problem? We just set this factor as 17, so that's longer. But over here, we would get the shorter length to be a greater number. So that would be problematic. That's why the 3x minus 5 cannot equal 17. We'd have problems if it did. So that was an impossible solution that way, so it has to be 10 feet.